Hello, welcome everyone. Last week we implemented the Fibonacci numbers. This week we are going to look at the anagrams dojo. The task is to find all the possible permutation of the letters in a given word. So I just opened the anagrams test file. We include the G-test header files and our implementation header. And I'm quickly writing the first test case, which will be to find all the possible permutation of the one letter word. And one thing we could first check is that the size, the number of these permutations is correct. So all possible permutation of one letter is 1. Have that as a statement. And of course we check that this, the only permutation that we can find is exactly the same letters that we are finding anagrams from. So that will specify the interface that we have for our anagram object. Of course we could not compile the test without implementation, but it's very good to write the first test case beforehand. Then we know what interface we should expect. And actually this interface looks very similar to the one provided by the standard vector class. So I was tempted to write the operator add and the size function here, but after another thought, I thought it would be better to inherit the interface from the vector class. Now we need to adjust our constructor. And we can also now use the functions provided by the vector directly. So our object is a kind of vector, so it has a push method to store the content. And currently we are dealing with a single letter word, so to find the permutation is just to save the letter that we were given. So that was easy. I got it to pass this test case just with the one line of the implementation. But now we will have a bigger challenge. We're going to have the two letters in our test case. So as before, we first check that the size will be correct. So let us put the anagrams of two letters and check the size. That should be 2. So we have the two possible words like AP. That should be anagrams, the first item in the anagrams object. And then we'll have the BA, right? BA. That should be the second object in the anagrams, and the size should be 2. So that is all we can check for the two-letter case. And obviously our very simple implementation is not dealing correctly with the two letters. And now we need to implement these two letters. It's quite challenging to go from one letter to another to two letters. We need to notice that there is also a kind of recursion going on. So basically we would need to take every letters in from our word that we're given and take that letter away, find all the anagrams from the rest of the word and prefix them with these letters that we took away. So let me write another function where we'll be adding quite many of other anagrams to our set. So I add the add function, and I mentioned about the prefix and the set of the letters. So that will be the two argument that we're taking. And first of all, we need to iterate through all the letters that we have in the given word. So all the letters that we have in this letters argument. I'm just writing the standard C++ for loop to iterate through a collection. So we start from the letters begin until letters end, just increment by 1. And now we need to take away the current letter from the letters. So I write the new letters variable. That would be the sum of the strings. The first string is from the very beginning until the current letter, that will until I, and the second string that we will concatenate will be from the next letter until the end of the string. The letter's end points not to the last letter, it points the one element afterwards, so that is possibly empty string. And the new prefix now should be our old prefix plus this letter that we have taken away, so plus letter pointed by I. So here let's just make a copy maybe of the old prefix, and then we can well, add this new letter with the pushback method. So yeah, I will point to a single letter, and single letters are element in a string, so we can push them back. We need to correct well, the name. Here I use the, let's say, C++11. I think they introduced this auto variable, so if it's possible to know a new variable type from its initialization, we don't need to specify it, so it's much faster to write auto than, let's say, standard string, or even if we have a much longer class. And then we have our terminate condition to terminate that recursion. So once we are run out of all the letters, that we interact through all the letters, we are left with empty set of the letters. Then all the word that we all the complete permutation is in our prefix. So we just push back, so save the prefix as as a permutation that we have found. This line is a bit too long. I think that looks quite nice. Okay. Yeah, the implementation is not too long. Looks nice, but it's failing. We get the actual size as 0. So since we are not in both test cases we got it as 0, since we are really not storing the prefixes, just this looks correct. We iterate for all the letters, and the string from the beginning to end. That is fine. We have the prefix. Oh, obviously one thing that I forgot is yes, I didn't call this function recursively, so we constructed this new prefix and new letter set, but we didn't call our function with those parameters. That's why it wasn't adding any elements. Now it's passing. The short troubleshooting session. Now we are done. So we can test also the free letters. And here we will have the size is now 6. So number of permutation is really like factorial of number of letters that were given. We can also like declare our object A. Then we will not need to write the anagrams ABC all the time. So then I can just every time just A.size and add operator. That should be 6. The first should be ABC. That should be the first one, so A from 0. The next one should be ABC. ACB. So first we permutate the two last letters. ACB, that should be first one, and I'll just write the last one, so that should be 5th. The second is BAC, and as I mentioned, the 5th one is the last one, and that should be, let's say, the reverse orders of C, B, A. Okay, check it. It's our implementation is still working. That's great. But if we have more letters in our word, let's say, it would be hard to check all the content. So let's just find if a particular permutation is in our set, and we can do that also using the standard vector methods. So we have a find method that works with the vector. So I write assert not equal, and we will see the reason why. The way find works, we need to give the first and the last iterator of the range, so and then the element that we're looking for. So let's check if DJOO is present in our anagram class, and if the find doesn't find the element, it will return the value of end in the collection. So while it doesn't compile, since we are missing the find method. Sometimes I forgot to give the prefix of standard namespace. We need to include the header file. This will be the algorithm header file. Now it's passing. So by being a kind of vector, we also make it possible to use all the algorithm function that works always with standard C++ containers. So we got much good implementation for free. And now we can test also the size of our implementation. So let's check some longer string, let's say Sunday DoJo, that will have let's count 8, 9, 10 letters. So this number of permutations in this Sunday DoJo should be equal to factorial of 10. Now to calculate the factorial of 10, we can filter that line through GNU-R program. It gives quite verbose output, but we are only interested in this number. That's a big number. Then we will also check how fast our implementation is. It will obviously take a few seconds maybe to calculate all the big number of anagrams. Let's check it. Yeah, it took 4 seconds. We have many thousands of elements in our vector. And in the last thing we could do is to, well, print our anagrams. Let's see if they are really finding all the permutations. And before we could use the standard find function, so also we can use the standard for each function. Then we can skip the for loop. So as before, we need to pass the iterator to beginning and end. So that's the standard way of specifying the range in C++. And now I'm writing the lambda function. It's also one thing that was introduced in the standard C++ 11. So we can write a function without need of giving it a name. So this can use this square bracket notation to note it, and the parameter list, and then just the query bracket and implementation. So here we just pass whatever as we got from the list to the cout. Okay. See if that works. Obviously it doesn't. Just a semicolon miss. Yes, we have our anagram, so we can see all the letters gets permutated. DoJo with the DOOJ, DJOO. It's quite nice. Great. I think that was all for today. Thank you.